because it's map work, we are going to have to swing to a map and back to the question quite a lot. So it's going to get quite irritating. You got to bear with me. All right, but we've got to look at the question, then look at the map, then look at the question, then look at the map. So just bear with me as we chop and change between the question and the map here. But let's have a look at the first one. It says here at the top, Welkom, which is probably also cold and wet tonight. Welkom is a town in the Free State. Lecture A is a road map showing part of the streets in Welkom. The town is known for having many traffic circles. I actually prefer a traffic circle compared to traffic lights. If you know how to use them, they actually keep the flow of the traffic running pretty smoothly. So here comes the first question. I don't know if you guys can see it. If it's too small, please shout. All right, I'm trying to fit as much as I can onto the screen here. Here comes the first question. Write down the general direction of the concourse circle from the shell circle. All right, so now we've got to look at our map. So I'll zoom into our map here. And there's a key here on the right hand side. So all these numbered dots are obviously the circles. And on the right here, you can see we have all the circle names. Okay, so looking for the concourse and the shell. Now, I don't know if you can see it, but number 3 here is shell. And then number 15 here is concourse. So I'm looking for 3, which is there. And I'm looking for 15, which is there. All right, so those are the 2 points that we're looking at in this question. All right, now I'm going to scoot over to the left a little bit because I want to read the question again one more time. The wording is important. It says, write down the general direction of the concourse from the shell. All right, shell is 3. I'll put an S here for shell, and concourse is 15. Of the concourse from shell. What is the direction of concourse from shell? Sonke, well done. Good question, Galen. All right, good question. Good. Awesome. Yes. Awesome. All right, so just a reminder on how we do this again. We can see up there on the top of the map is an arrow for north. Usually most maps have an arrow pointing up for north, directly upwards. And now when they say, what is that direction from one to the other, the point that you are moving from, you should think of a compass point on that. So I'm putting in fact, let's put a different color so you guys can see it. I want to put a compass point or a compass on the point I'm going from. All right. So I'm putting this green compass on the shell circle, and then I'm going to draw a red line from the shell circle to the concourse circle over there. So you can see the green compass and the red line, and then that should help you out. All right. So where you're going from gets the compass, and then you draw the line out, and we all know that this is north, this is south, this is west, and this is east. Okay. And this red line here is between the south and the west, halfway. So we say southwest. Okay, so the key here is to know where you're going from. Put your compass there. Imagine there's a compass there on the point you're going from. Draw a line to the other one, and that will help you work out the general direction. All right, nice and easy. Well done. Remember, if there's any queries or questions, please feel free to ask. Next question, here we go, number 2. A railway line passes through Milner Road, Othello, Ararat, Kopi, and Alliance streets. Explain how it is shown on the map that the road is actually situated above the railway line. How do they show on the map that the road is above the railway line? So if we look at this diagram, what is the railway line? Well, we can see here in the key over there in the top right hand side, the railway line is this one here. Okay, they want to know, how does this map show that the road is above the railway line? You're going to have to describe this. You can't calculate it. So who would like to come online and describe, how do we know that the road is running above the railway line? How do we know from this map that the road is above the railway line? Anybody?
Somebody.
Somebody.
Anybody on this rainy day?
Ndinenga. All right.
Please check for a message on your screen that's going to ask you. There we go.
Ndinenga, you
Good
there?
evening, sir.
Good evening. How are you?
Good, thanks to yourself, sir.
Is it cold and wet where you are?
Yeah, it's quite freezing, and the cold is not that bad since I've been in the house the whole day, so I can't really feel the cold.
I'm feeling it, man. I think something wrong with me. I'm feeling it tonight. It is. I'm
So,
miserable.
so what I see here is
It's hard to describe, isn't
a
it?
cup of coffee will keep the cold away, sir.
How would you describe it? How does this map show?
It's that I can't find the right word for it, but I'd say if you look at the railway, you'll see that it's not joined. It's not fully joined properly. I don't know if
Yeah.
I put it in the right
Yeah,
context.
no, you're right. And
But
look,
it's
I
not.
know you.
It's not. Not.
I know you can see it. It's hard to explain,
It's
isn't
not
it?
joined. Yeah, it's quite difficult to explain, sir. But it's for the fact that you can see that it's not joined properly, and there's the roads in between. I feel like that's what tells that okay, the road is over the railway, and the railway is under the road.
I agree with you. I agree with you. So you could use words like the railway line that is drawn stops when it reaches the road and continues on the other side. You could use words like that. So the railway lines drawn stop at the road and will continue on the other side of the road. That is an indication that they're going underneath the road. Yes, we can all see it. I mean, it makes sense, but how do you describe that?
It's putting it in context. That's the problem. Like putting it in words.
Yeah, it's to
it's quite difficult.
Use your words. But if your words make sense in any way, the marker will have to give you the 2 marks here. So don't worry too much about it, what words you use. But if your words make sense, and just write what you see, the lines stop on either side of the road. They do not go over, the lines do not cross the road lines, then you'll get your marks for that.
Yes, sir.
All right, Deniga, thank you so much for the help there. All right, excellent.
Thank you, no problem.
Let's move on to the next question and have a look. Okay. Now, first of all, let's just write the answer here. So I'm going to write southwest over here. And then over here, I will say railway lines drawn. Do not cross road lines. So something like that. Okay. All right, let's move down to the next one. Name the traffic circle that connects 5 roads. Name the traffic circle that connects 5 roads. I don't know if you can see the names there on the right-hand side, those little numbers. There we go. Name the traffic circle that connects 5 roads. I don't know if you can see it. Say the number or the name if you want. Name the traffic circle that connects 5 roads. You can just say the number if you can see it, or the name. It's up to you. You can type it in chat. Which traffic circle connects 5 roads? Can you guys see? Twenty's got 3. Yeah, I would say 11. Yeah, I would say 11. I would say 11 as well. It's 11, which is Toyota. Yeah. All right. So it's 11 there, which is Toyota. So 20's got 3. I've sold it with 4, but because Toyota or number 11's got these 2, Over here on the left, they come into it there. That would be 5. Yep, I think you guys are right. I would say 11, Toyota. Now, they didn't say give the number of the traffic circle. They said name it. So you would have to go to the number on the key and give the name. So you would have to write Toyota for this to get your 2 marks. Okay. All right. Not too bad. Question number 4. Here we go. And you know it's coming, hey? Usually with these map work questions, there's going to be one, or there is often one where they ask you to describe the route. Okay, so describe the route that will be taken by a car entering the town on the stateway from the industrial area if it's heading to point X at Dagbreek, passing by the city council building on the left. So you're coming into town from stateway industrial area, heading to Dagbreek marked X, passing the city council building on your left. Now what I'm going to do, excuse me, is copy this question and bring it up here to the top so we can read it while we look. Okay, so I'm going to plop it over here at the top. All right, there we go. So there's a question at the top of the map. Okay, and I need someone to come online and help me with this. So I need you to describe the route that will be taken by a car if you're entering town at the stateway from the industrial area. Now, where is the industrial area? Can you guys see an industrial area or the stateway? I'm sure. Ah, here we go. All right, there's industrial area and there's the X. Okay, so who would like to come online and help me out here? We're going to describe the route. Okay, so whatever words we say, we will have to write down in the exam. Okay, but let's just use verbal instructions here. We're coming in on this road from the industrial area. All right, I'll show you a little red arrow. That's what we're coming into. And we are trying to get to point X here at Dagbreek, sorry. And we have to pass the city council building on the left. The city council building is over here. We've got to pass that on the left. Okay, so who would like to try this one out? Anybody out there? How do we describe this route? Using your words. Right, no calculations yet in this whole question. We're just using words here so far. Anyone want to try? If not, I'll give it a bash. All right, let me try this one out here and we'll give you guys. Oh, there we go. How are you there? I'm good. Hey, have you started? You must have started writing already, eh?
Yeah, I started last week.
How's it going?
It's fine, but this week I'm on a break, so that's good.
Okay, and when's math lit?
I did math paper 1 on Friday.
How did it go?
It went well. It went very well. It was
Good.
It was a beautiful paper.
When you say beautiful, what like you recognized the questions or you just felt good about it?
Both actually. Like
Awesome.
I even took a nap at the end of it. In the last 30 minutes. The whole class actually took a nap because it's a very good paper.
All right, good. Good. That's positive. All right, let's try this one out. Describe the route from the industrial area where the red arrow is, past the city council building circled over there and to the X.
So I'd say you head straight on the industrial area road, and then you turn left, and then when you get to, I'd say, I don't know, a crossroad, you're gonna turn left again, and then turn right on Stateway.
Stateway, yeah,
Stateway Road, and then you're gonna turn right on Arrett Road, and so you get to the X. Yeah.
Okay, cool. So we can use words like that. So turn left, turn right, and turn onto Stateway, turn right onto Arrett. Those are the words we need to use. Perfect. So now we've got to make sure that we pass the city council building on our left. So what we could also do is instead of turning at that that number 11 there, we could go straight on this road there and continue past the city council building and then turn right over here. We could turn right again, and then we add the X over there. Good, thank you, Khabo. Just remember, when you use your words for these, you've got to say left and right. Okay, so you're using turn left, turn right. Also, if you can use the traffic circle names here. So for example, head straight on the industrial area road, turn left in the industry traffic light, which is that one. Continue on until you reach the Toyota, not traffic light, traffic circle. You could also, for traffic circles, you could say take the second turn left, right? Because when you're in a traffic circle, there's a whole lot of turns that you could take from the traffic circle. You could say, in this case, for this traffic circle number 11, we are taking not the first turn left, but the second turn left, because everyone's going around clockwise. So you would take the second turn left, go to the bingo traffic circle, go straight over the traffic circle. You could use that word, past the city council building, and then turn right, head towards number 9, which is the Delta traffic circle, pass over the traffic circle or through the traffic circle. When you get to number 3, which is the Shell traffic circle, take your second left. When I say left, take your second exit, all right? But you'll be turning, it looks like you're turning right, and then you get to the number 4, the engine traffic circle, the last one there, you will take your first left out of the traffic circle and pass Dagbrek on your left-hand side. Yes, Sonke, that's exactly what I mean. So first exit out of a traffic circle, or pass through the traffic, straight through the traffic circle. Yes, so for traffic circles, we're taking exits out of it. Okay, because it's this big circle that everyone's driving round and round and round, and the only way to get out of a traffic circle is to turn left. You always have to turn left out of a traffic circle. All right, so it's an exit, your second exit or your third exit out of the traffic circle. Okay, all right, let's move on to the next question. We've got to get some calculations done here, guys. All right, I'm sure your pens and calculators are getting cold there. Let's have a look. I'm not even going to write this paragraph down. Here we go. Number 5. Finally, we get to the calculation. The actual distance from exiting the, you see how they use the word exit here? The actual distance from exiting the alpha circle to entering the engine circle is 500 meters. The actual distance from exiting circle 13 to entering circle 14 in Stateway is 1.4 kilometers. Determine by measurement whether the map is drawn to scale. Okay, so what we're going to do is, we don't have a ruler here, all right? So we're going to try and test to see, and we're going to use our own measurements here. Let's see if we can be proportionate. So exiting alpha to entering engine. Let's go to the map. Exiting alpha to entering engine. Where is alpha on the right here? Alpha is number 8. There's alpha. Engine is number 3. So from exiting alpha to entering engine is a certain ruler measurement. Okay, so it's this distance here between the two traffic circles, and they say in the real world that is 500 meters. Then they say, let's go to the question again. Exiting circle 13, entering circle 14 is 1.4. 13 to 14. All right, 13 to 14 is 1.4. So this one here is 1.4. Now, let's not think about the measurements they give us. Let's look at the map, okay? So let's pretend that from Shell to Alpha, or Alpha to Shell, let's imagine a ruler measurement of, let's say, 2 centimeters, okay? If I call that red line there 2 centimeters, how long do you think this blue one, this blue arrow is over here at the bottom? if the top one, the red line there is 2, how long do you think this blue one from 13 to 14 is? Centimeters we're talking about now. So let's pretend you measured the red one as 2. How many centimeters would you guys estimate that the blue one is? Yeah, I agree with you. I think it's probably double. All right. Maybe a bit short of double, but let's call it double. Okay. So let's call it 4. So let's say the blue one is 4. If you measure the red one as 2, then the blue one is 4. I'm with you. Let's use that. We're going to use that now. Okay. So we got 2 sections that we are measuring here. This is what I think they're trying to say. So if we've got a 2 centimeter relationship, gives us 500 meters, and a 4 centimeter relationship represents 1,4 kilometers. All right. Now, I know you can see already we've got problems here. But anyway, let's show by calculation, because that's what they say. We're going to measure and show by calculation. So on the left-hand side, we measured these 2 values. And on the right-hand side, this is what they tell us it's supposed to be in the real world. Okay. Now, what I'm going to do is, first of all, change the bottom one's kilometers into meters. So we're going to multiply this by 1,000. Okay. That'll change this bottom one to 1,400 meters. All right. Now, I'm not going to change this too much. In fact, let me pull this out and compare them next to each other like this. All right, so there we go. And I'm going to draw a line between them to show that these are 2 separate things. Okay, now I'm going to work on the left-hand side, and I'm going to change this to 1 on the left. 1 is 2. All right, which means if I change the 2 to a 1, I'm dividing by 2. Then I need to divide this side of the ratio by 2 as well. That would give me 1 is to 250 meters. If I do something similar to the right-hand side, the other road we measured, I want to make this a 1. So I'm going to divide that by 4. That'll give me a 1. And on the other side here, I'm also going to divide this by 4. And then I'm going to get my calculator out and see if this gets me something similar, 350. All right. So 1 centimeter on the left, for the road we measured on the left here, 1 centimeter equals 250 meters. But on the right-hand side here, 1 centimeter represented 350 meters here. Now, if you measured accurately, all right, and if the map is drawn to scale, these 2 ratios should be the same if these distances they gave us are correct. If they're saying these distances they gave us here are in fact true, then when the map is to scale, when we measure accurately with a ruler, what we measured should give us the same ratio here. Are you guys happy with that? Right? Because we're using the map scale and comparing the answers that the question's giving us here. So we're using the scale of the map and the actual values they give us to say, is the map true? Now, if we measure correctly, these values should be the same. They should. So number 1, you've got to measure correctly. Make sure you're measuring accurately. And then when you do this kind of calculation, when you're comparing apples with apples, and what I mean by apples with apples, I'm changing this to 1 centimeter on the left represents a certain number of meters on the right. Okay, I've got to compare them both. And when I do this, when I bring them both back down to 1 is to something, I can see that these values are not the same. Now, you've got to be careful with this kind of thing, because if you don't measure correctly, you will be off anyway, slightly. But in this case, I think the error is significant enough that we can say that something's not right with this map. Okay, so if you measure correctly, it should be the same. But if it isn't, and it's quite obvious, this is not like 250 versus 270. All right, this is not 250 on the left and 270 on the right. 250 and 350 is a big difference. Okay. All right. So I would say that the scale is not correct, or that the values they gave us here is not correct. Okay. But If we read the question, it says the actual distance from the one circle to the other in the first instance there is 500. The actual distance from two other circles is 1.4, determined by measurement whether the map is drawn to scale. Well, using our ruler and the measurements we have here, which is 2 centimeters and 4 centimeters, and using their information in a ratio, these ratios are different. No, it wouldn't make a difference. We could do that. You're still going to get a different answer. In fact, you'd get 0.25 on the left and 0.35 on the right. That's all you would get. So all we're doing is taking a ruler measurement, a 1 centimeter ruler measurement, and seeing, using their numbers, how much distance we get with 1 centimeter for these two different distances on the map. And they should work out. So either the data they gave us, the numbers they gave us here is wrong, or the map is not to scale. Now, obviously, they're not asking, are our numbers wrong? They're asking, is the map drawn to scale? And according to these big differences between the ratios, this map is not to scale. I hope you guys understand that. Okay. Now, the point of this question is to compare apples with apples. So we created two ratios using those two distances and the information they gave us, and brought these two ratios down to 1 is to something. Both must be the same. 1 is to something. And we can see here, no. That should be the same for both of them. All right, it should be the same. For example, if the scale was the same, and we had 2 centimeters represents 500 meters for the one distance, then when we measure 4 centimeters for another distance, that should give us 1,000 meters. All right, because we're just doubling it, but it didn't. It gave us 1,400. So something's not right. Okay, I hope you guys can see that. Are there any questions? All right, if there's no questions, I'm going to move on to the next one. Let's see what they have. So here we have question 6.
Speak now, don't ever hold your peace.
Speak now, don't ever hold your peace. Translated means you're always allowed to ask questions anytime. Question 6. Samuel stated that it took him 5 minutes to cover the distance of 4 kilometers in this town. Verify with calculations whether the car was traveling within the speed limit. Okay, so verify with calculations. Verify whether the car was traveling within the speed limit. So we need to check the speed of the car, and they give us a formula to work out speed. Now, what's the speed limit? Well, if we go back up to the map, I don't know if you noticed it. Down here at the bottom of the map, there's a little note. It's very small, so maybe you didn't notice it. Over there, highlighted in yellow, it says the speed limit on public roads in an urban area is 60 kilometers per hour. So we got to test that this guy was going 60 kilometers per hour. Okay. All right, here we go. Now, who would like to help me with this one? What do I do? Yes, Tando. That's what we're testing. Is he going 60 kilometers per hour? Who would like to help me with this one? And you know what? We've been here a whole year, and I still will not forget, Kia, and I'm sure you don't too, the first time we did a speed, distance, and time question. I'll never forget that day. Anyone like to help me with this? You guys, please don't make me do these all by myself tonight. I need to work out distance.
Somebody needs to talk to us.
There we go. How are you doing?
I'm good, sir.
Okay.
I think you have to first work out the speed of the given on I don't think I'm making sense, but yeah.
So they actually want us to check the speed. Have you noticed that they want us to check speed, but they don't give us a formula for speed, they give us a formula for distance.
Yeah, so you have to substitute the 5 minutes into the time, and then the 4 kilometers into the distance.
Okay, so what Khab was saying is we can put a value in here for time and a value in here for distance, and then we're going to have to rearrange the formula to check the speed. Is that what you're saying?
Yes.
Okay, cool. Let's do that. So let's just write T for time. Before I put it in, what is the time? 5 minutes. And the distance that we have to put in is going to be 4 kilometers. Now, are these numbers ready to go into this formula?
Yes, I don't know.
So if we put in minutes and kilometers, the speed we will get out is kilometers per minute. Now we have to check this speed.
Oh, you have to change it to hours.
Yeah, so we need to compare against that speed, which is kilometers per hour, and they've given us time in minutes. So we will have to change this 5 minutes into hours first of all. And how do we do that?
Times by 60.
Or divide by 60.
Divide by 60, sorry.
Yes, I can hear you on a break this week. We have to divide by 60. Okay, so 5 out of 60 minutes is how many hours? Oh, I want to do this horrible decimal. 0.8333. All right, let me just write it quite a few. 0.83. Was it 0.8? It was 0.8.
Yeah.
So 0.8333 hours. Okay, so that's the hours. Now, why am I putting in decimal hours? Because like we spoke about this the first time we did this formula. This formula only takes decimal hours. Okay, so you have to change it into a decimal format here. Now the kilometers are good. We can put those straight in. Now we're going to go to the formula. I'll write it. Let me just put it straight in anyway. So we've got 4 kilometers for distance equals, I'll write S for speed times 0.083333 hours. All right, Kaba, what do I do now?
You're gonna have to get the S on its own.
Very good. And how do I do that?
To divide 0, you're gonna have to divide by 0,08333.
Absolutely.
Both sides.
Good. So we want to get rid of this number. So to get rid of this number, you divide by that number. All right. So we'll divide by this number here, and that'll get rid of it on the right-hand side. Now you might be thinking, why where's it going to go? Well, what you do on the right-hand side, it also must be done on the left-hand side. So there's our number there, being divided on the left-hand side as well. So we're dividing by this number, like Hubble says, because she wants to get rid of it and just have the S by itself. All right, now let's rewrite this formula as it stands right now. So now we've got the S by itself, and it equals to all of this. And then we're going to reach for the calculator and put this in and check what this speed is. Is this person speeding? Remember, it can't go over 60.
It equals 48.
48 kilometers per hour. All right. So
they're not speeding.
they're not speeding. Let's go back to the question. It says Samuel. All right, his name's Samuel. So therefore, Samuel is not speeding. Okay. Are there any questions? Kabo, thank you so much for your assistance. I really appreciate it. Are there any questions about this, ladies and gentlemen? Are you all happy with how we did it? Anything strange here that you might look at and think, why? Why do they do this? Why do they do that? Or are you all good? I know it's cold out there, but are we all good in terms of this answer? Very good. All right, Kayana, I saw your answer there. Just check and see what was different between what you did and what we did here, that we are getting a different answer. Are we all good, ladies and gentlemen? I'm going to be moving on. So I said 4 5 times 60. And I got the same answer. Yes. So okay, so that'll be fine. Because if you look at it like that, so 4 divided by 5, oh, so you said 4 times, sorry. You said, let me check what you said, yeah. 4 divided 5 times 60. Four divided by 5 times 60. That's very interesting. Soki, how did that look on your calculator? Soki, just check your screen there. Should be a prompt to unmute. Just explain to me how that looked on your calculator. How did you type it out on the calculator?
So I said 4 divided by 5, so 4 over 5,
Yeah.
and then times 60. That's what I did.
Hmm. 4 divided by. Oh yes. Okay, I'm with. All right, I've got it now. Okay. Let me just explain what Soki did then. If you guys are thinking, what, why does that work? Well, look at this. 4 divided by. I see ours over here at the top is 5 over 60. Now Sonki's got 5 times 60. Now just hold on. Let's just see if this works out mathematically. 5 over 60. So 4 divided by, and I said this is 5 over 60. 4 divided by 5 divided by 60. All right. So on our calculation, we said 4 divided by 5 divided by 60, which gave us, and the 5 divided by 60 gave us 0.083333, right? But you know in mathematics that when you divide by fractions, we don't like to divide by fractions. So what we do is we tip and times them. So this is the same as 4 over 1 divided by 5 over 60. And that we tip and times, that's 4 over 1 times 60 over 5. And then when you put these two together, it's 4 times 60 over 5, or 4 over 5 times 60. It's the same thing. All right, so Sonky, you're saying the same thing.
Yes, sir.
I'm zigging, you zagging, but we're getting to the same place.
Yes, sir.
All right, excellent. Okay, so yes, mathematically that is absolutely fine. You zig, I zag, we're getting there. We get to the same area. All right, any other questions? Otherwise, we're going to move on. There's other few little ones here that I want to have a look at. All right, let's have a look. What else do we have? All right, question number 7. Let's have a look. The same painters, or anyway, there's some painters that are involved in this, must repaint all the road markings at all the traffic circles in Welcome. Layer 2 says the probability, guys, check it out again. They snuck in a probability question into here, into a map work question. Can you believe it? Layer 2 says the probability that the painters are at a circle in Stateway is 0.15. Verify whether her statement is valid. Stand must repaint all the road markings at all the traffic circles. Later says the probability that the painters are at a circle in Stateway is 0.15. Now, where are circles in Stateway? Let's go have a look. Let's go have a look. Where is Stateway? Stateway, Stateway, Stateway. All right, so where on this map do they talk about Stateway? There we go. All right, so here is a road. Okay, I'll highlight it. There is Stateway. I'm highlighting that road in blue. And Ledger says that when they are painting all the traffic circles, the probability that there would be in Stateway, the road is 0.15. Now, what that means is the probability that there'll be in either 15, 14, and 13, those traffic circles, which are on stateway, is 0.15. So what we're testing out to see is what's the probability of being in these 3 traffic circles out of all the possible traffic circles. Now, if we look at all the numbers on the right-hand side here, we've got traffic circles that go from 1 to 20. So what's the probability of being in these 3 traffic circles, 13, 14, and 15, which are on stateway? All right, so underneath here, I'll show you. So what's the probability that we are on the stateway traffic circles? It's those 3 out of 20. All right, it's 3 out of 20. Yes. Now we're going to check this by making it a decimal. All right, so let's go here to the calculator and go down to the bottom and check this answer. And here we go. 0.15. She is correct. Yep, 0.15. She is correct. All right, so in a very strange way, they wanted us to check what's the probability of being on those 3 traffic circles. All right. The statement is valid. Absolutely. Valid statement. I hope you all got that. I hope you all got that. All right, let's move on to the next set of questions. Oh, okay. Here we go. We got a scenario here where we have Tumi received the bursary to study at the University of Victoria in Canada. She traveled from the University of Victoria to Victoria downtown, which is like in Victoria City, the city center, okay? NHIA shows the map and 2 routes that she could have used to travel on. All right, so on the right-hand side, we should have a map. In fact, there are 3 routes, okay? So we're going from the top there, the top left. I'll zoom out a little bit. We're going from the top left there. You can see the start of the route is up here. And we're going down to Victoria downtown, which is in the bottom left-hand side there. There are 3 routes. This is what Google Map does for you. Gives you all kinds of options and gives you the best one. So we've got 2 gray ones and 1 blue one. The blue one is the one we're talking about here. All right. And we can see that there's information about that route there, and that route there. The blue route that we see is supposedly taking 14 minutes and it's 6.8 kilometers long. Not wrong, long. Okay, it's 6.8 kilometers long. Now, on the left-hand side, what Google Maps also does for you is it gives you a breakdown step by step of the directions that you have to take. So here is a summary of the route. Number 1 is head somewhere or something on Cedar Hill Road, crossroad towards Crestview. You got to do 190 meters. Step number 2, turn right onto Cadborough Road. Okay. Number 3, continue onto 4th Street, drive a certain number of kilometers. Number 4, slight right into Pandora Avenue, drive 2.1, and you've reached your destination. So Google Maps gives you this summary of all the directions. And then when you press go, the lady starts to speak to you on your phone or on your laptop or whatever. Okay. In 190 meters, you're going to turn right. All right. So these are the instructions the lady actually reads to you. Let's see what questions they have. We'll do a couple of them. It says, in which general direction did she head from Cedar Hill Crossroad towards Crestview? So the question is down here at the bottom. In which general direction did she head from Cedar Hill Crossroad towards Crestview? So that's the first part of this journey, number 1. Now, if we go up to the top of the map here, there it is there. This is the first part of the journey. So before you turn right, this is the first step there. So in which general direction is the person going along that section of the route? Can anybody type in chat? In which general direction is the person going if they're going on that part of the route there? What direction is that? Remember, general direction, you've got to use north, south, west, or east. So which direction is this one here? Which direction are you heading? Anyone want to take a guess? You can type in chat. Oh, it's crickets. It's too cold. Yes, southeast would be my best guess as well. All right, so it's something like that, close to that. So this, yeah, I would say southeast as well. Yes. Southeast. Yes, very good. Okay, let's try one more. What other questions do they have? I would also say southeast. Let's go down and see what they have. Determine the distance that she traveled on Fort Street. Now, we can see here that this part of the route is the Fort Street section. Continue onto Fort Street and drive a certain number of kilometers. So how would we find out how far she drove on Fort Street? How could we tell that? This is the last question for tonight. How far did she travel on Fort Street? How do we figure this out, ladies and gentlemen? We'll do this one and then we'll call it a night. Anybody?
Somebody.
You see, our sound is getting better. We even got echo now. We've got echo on our album. We are developing our musical talent here. This album.
It's an original sound. No one can top this.
Oh my gosh, you're sitting there at the sound desk. 92. Okay, yeah, that's quite big, eh? Just remember that in the question they say that the total journey takes 6.8 kilometers. So when Google Maps shows you your journey, they show you that your total is 6.8 kilometers. So for this one, what we'd have to do is take these values, 190 meters. Remember, that's meters, 3.2 kilometers, and 2.1 kilometers. And we'd have to subtract it from the 6.8. So we'd have to say 6.8, all right, minus. And then the first part is 190 meters. You'd have to divide this by 1,000. And that'll give you 0.19 kilometers. So I'm changing it all to kilometers. So 0.19 plus the 3.2 and the 2.1. So I'd have to subtract all these other distances from the 6.8, and that will give me my answer there. Okay. All right. We're going to call it a night.